Yeah, comes on everyone. Hope everyone has tried the homework problem. Any answers? Let's see. Did you guys even try or forgot completely about the problem until now? So when I give you some homework problem, there is a reason for that. The reason you got so much time is the problem is good. You might think like, I'm not getting it's a waste of time. It's not like that. When you try hard problems, even if you don't get it, your brain, right? Your the threshold of difficulty in your brain, right, changes. Your brain will start thinking, I have seen tougher problems. And once you get that feeling, right, even the moderate questions, you won't get scared to try. It's important you try tough problems, even if you don't get an answer. So when I say this, I remember a story. I'll tell you the story. So in a village, right, there is a boy who is weak, thin and frail, not that strong. But he always had a dream of, becoming strong. Like, मुझे भी थोड़ा strong बनना है. So one day he came to know a sage is passing through the village, right? And people are taking advice from, from the sage. Like, people have issues and all. तो ऐसा, क्या करना है? So this boy also goes to the sage and says, sage, मुझे, I want to become strong. And you tell me, I will do. Like, I want to become strong. And the sage says, okay, can you see that hill over there? There is a big stone. He said, yes, go and push it. Getting it? He said, just go and push it. So this boy said, okay. He went there. And this boy started pushing. So every day he was pushing it. So said, okay, Sage ne bola to karenge. The morning he went, he tried to push maybe for half an hour, 1 hour, tried, it didn't move inch. He left, he went in the evening again, pushed, nothing happened. Next day pushed, nothing happened. Next day, nothing happened. Nothing happened. He did this for months. वो होता है important. एक बार push करके आना नहीं है. Fight है. He pushed. He tried almost for 2 to 3 months and then said, yeah, this is not going to happen. And then finally disappointed, he went back to the sage. Said, Sage, you told me to push the stone. I really tried my best. Matlab, it's not like I just tried once or twice. Every day morning, every day evening, religiously, I used to go and push it and give my best. And I tried my best for almost 2.5 months. And that bloody stone didn't move a single inch. I said, I'm sorry I failed you. And the sage said, did I ever tell you to move the stone? All that I said was to go and push the stone. Then he said, look at yourself. And when the boy looked at himself, the muscles have grown because of that constant pushing every day. His muscles have, has become stronger. He started developing biceps. He got more muscles. He's more muscular. And then he said, there, you have become strong. The task was never to move the stone. The boy assumed it. The task was always about the effort. The task was to go and push the stone. The boy interpreted thinking like, jab tak मैं stone push move nahi karunga, I'm not going to become strong. So that is the point. So it was never about you figuring out the question. It was always about how much fight did you actually keep. Who knows? One day he might actually push it. Let's go ahead with the question. So how do we start with this? The Trosh reward diagram. So when this thing is here, and this thing is just about to lose contact, meaning they're still just touching. So this is your capital M, this is your small m. This will be going with velocity v2. They will not have same speeds. And remember, this Sphere here is going in a circle. So this will have a speed v1. Agreed? This angle is 60 degrees. So this angle will be 30 degrees because that's 90 and this is 60, 30, 90. No, that is also 60 degrees only. 60 degrees because this is 30 degrees. Hope everyone is clear with the angles. Now we know when they're touching here, this is your common normal, the green line. Rigid body constraint. If two surfaces are touching each other, velocity along the common normal must be same. This is the diagram just before losing contact. That means V2 will be equal to V1 cos 60. This is your equation. V2 is V1 by 2. Clear? Or let me just write V1 is equal to 2V2. This is your first equation. Second one. Initially the sphere was here. Then finally the sphere came somewhere here. This was 60 degrees. So if you look at this height here, this was L cos 60. That means this is also L by 2. So this guy is going with V1 and this guy is going with V2. Loss in potential energy is gain in kinetic energy. The block height is not changing. The only one who's losing energy is the sphere. Loss in potential energy is gain in kinetic energy. This is what I was saying. There might be 10 steps in the problem. Did you figure out at least 2 steps? Then I think you did a good job. But if you have not even tried, you're just staring at it and you're doing it, then that is what will make you different from others when you put a fight. What looks difficult and impossible today, think about it. First time when people were actually trying to invent a semiconductor chip, right, or a transistor diode, it must have been hell, right? It must have been big nonsense. They could have said like, yeah, this is all nonsense, who will do so much effort? Chhod dete. Today we won't have smartphones. The game always starts that way. So this is MGL. Remember, the masses are different. So do please put a fight. Even though it looks difficult, give your best. Half mv2 square. This is your second equation. Check. Till here, at least, you should have figured it out. You had 4 days of time. If not the constraints part, at least the energy part. But we have how many variables? V1, V2, MM. So we need one more equation. This is where I saw generally most people get stuck with the third one. They don't figure out the third equation. Look at one is the rigid body constraint and the right one is the conservation of energy. Any ideas on where to get the third equation from? See, the third equation comes from this is a tougher one actually. So when this sphere is here, now understand you're just before losing contact, meaning you're still touching, but you just lost contact. So when you just lose contact, it is about to lose contact. That is, normal reaction becomes 0. Now, if there is no normal reaction, acceleration of capital M is 0. Do you agree? There is no one pushing this block AM. You just lost contact. There is no horizontal force. But if you look at this sphere here, we have 2 accelerations. We have A centripetal and we have A tangential. This guy is going in a circle. And we know this is a normal. So again, the same story. Acceleration along the normal must be same. So this also goes from rigid body constraint, but this time we use for acceleration. But that sphere doesn't have one acceleration, it has two accelerations. So if you just draw the FPD of the sphere, if you look at the forces, we have tension, we have mg ka components. This is 60. This is mg cos 60. This is mg sine 60. And what about the acceleration? Since you're going in a circle, we have a centripetal and we have a tangential. A centripetal is v1 square by r. A tangential is g sine 60. The only one who's providing acceleration is this. So now when you take these components again, a centripetal, a tangential. So indirectly you're saying in the horizontal direction, the resultant is 0, right? So what is the resultant in the horizontal direction? This was 60, this was 30, and this was 60. So a tangential cos 60 minus a centripetal cos 30 must be equal to acceleration of the big block capital M. So if they were touching each other, this was the relation. Do you guys agree with this thing? If they are touching each other, acceleration along the normal and velocity along the normal must be same. Both must be same. If acceleration or velocity is not same, that is when they'll separate out. So when they're about to lose contact, AM becomes 0. Now A tangential is G sine 60, cos 60. A centripetal is V1 square by L cos 30 equal to 0. Cos 30 and sine 60 will cancel. We will get G by 2 is equal to V1 square by L. This is your equation 3. Please check. We actually get two equations from the rigid body constraint. One is the velocity, V1 is 2V2. Second is conservation of energy. The third one is your acceleration along the normal. Please check the steps. Now we have all the data that we need. Any step you're not convinced, how did I get that AC? How did I get a V1? Why is AM 0? Why is N 0? Anything you're not clear, please don't hesitate to ask. And then after today class gets over, before sleeping, take a pen and paper and solve all these problems again. It's okay if you don't get it, but after teaching also, if you're not going to try it again once more, then that is your lack of commitment. You should not feel bad when you didn't get a question, but you should feel ashamed when you don't try it again. That's the difference. Never blame yourself, for trying and failing, but you should definitely blame yourself for not even trying. Clear? Next one. Now we solve these three equations. Now, please don't think this is about physics, huh? Physics is just a way to show your commitment. Something like a subject which you said you want to do IIT, and if you're not committed for this, in life going ahead, no matter what you do, you will show the same lack of commitment. That could be anything. And that will be a problem. 10 years down the line, maybe one day you'll realize this is what I really want to do in life. But because you didn't develop that abilities and skills, to sit and work at something, with focus, you will not get it what you want. And that day you'll realize, like, oh shit, it is too late. So if you see the equations, V1 is to V2. That was your equation 1. The second was energy conservation. mgly2 is half mv1 square plus half capital mv2 square. And the second one was v1 square is gly2. Try, still confused, Wednesday you can again ask me, there's no issue as such. So there, we are done. We just need to solve this. So dump everything here. Take a So this would be mgl by 2 half m v1 square. V1 square is gl by 2 plus half capital M v2 square. V2 square is v1 by 2 whole square. Which is v1 square by 4. So 1 by 4 and v1 square is gl by 2. GL cancels, 2 will cancel. We get m is equal to m by 2 plus m by 8. M by 2 is m by 8. M by m is 4 is to 1. Check. So this thing, what I gave you the question that it will lose contact at 60 degrees will happen only for this ratio of mass. If you change this ratio, angle will change. Like I said, once you got all the three equations, it's just a matter of solving. Clear? Any doubts on this? Kritik, Om, Arush, Farhan, clear with this? Nabia, Devansh, clear? Lakshita, Archana, clear? Pramiti, Shashwat, Vishnu, go ahead. Saumitra, clear? Yeah. Clear, na, Saumitra? Why are you so hesitating? Yes, no. Confused, please ask, don't hesitate.
Actually, I joined a bit late, so I actually missed the explanation.
You missed it out. Yeah. Be on time, don't miss it out.
Actually, I attempted again today. I'll attempt it once.
Yeah. Try it again on your own, and then recording is there, you can watch it. But if you have not tried this at all, I would say spend another 10-15 minutes and then you check out the solution.
Okay, sir.
Next one. So we got a block of mass m. We got a block of mass 2m. This is rough. Coefficient of friction is mu. This block m is smooth, okay? There is no friction for this guy. And now we are applying force F. Initially, the spring is in natural length. So the question is find the minimum force. Now, if I push this block, what do you think will happen? This block will come little front, the spring will compress. If you push it more, the spring will compress. At one point, the spring force is so much that 2m will move, right? The reason 2m doesn't move is because of the friction here that is blocking you from going. But if the spring keeps on getting compressed more and more, at one point it will push through. So find the minimum m so that 2m block just moves. Just moves. Any answers? You got an answer? Do type in the chat box. Two mu mg. Now again, what you guys did, you thought when the spring force becomes equal to 2 mg, you will move. That is true, but there is a catch. Remember last time we discussed, the block does not stop at mean position. The block will always go double. That means you need not actually apply so much force. So see how to do this thing. So this is my state one. So as you're pushing the block, at some point the block will reach somewhere here, and this is where you're about to move the block. So let this distance be x. So now if you look at the force here, this is 2 mu mg. This is your spring force, which is k. Since the block is about to move, kx is equal to 2 mu mg. This is my state one. This is my state two. So what is work done by force? Work done by force is F into X. What is energy in state one? Energy in state one. Potential energy, spring potential energy is zero. Kinetic energy is zero. No one is moving. Gravitational potential energy is zero because it is on the same level. State two, gravitational potential energy zero, same level. This will come to rest again, right? It will just stop. Getting it? The main thing is that it just stops. Spring potential energy half kx square. Kinetic energy is zero. So it is going to turn back now. They are done. So work done by forces is equal to E initial minus E final minus E initial, state two minus state one. So Fx is equal to half kx square. F is equal to half kx, which is mu mg. So when you apply 2 mu mg, agreed, the block will move, but you're asking for minimum. Means you're compressing the spring more than required. Since you're about to stop, so the idea was this. You did this thing, right? You thought when the force F becomes equal to kx becomes equal to 2 mu mg, right? That was a mistake. When F becomes equal to kx and kx equal to mg, do you think the block is at rest? The block will have maximum speed. मतलब block अभी भी और आगे जाएगा ना? The spring will still continue to compress. So that means this is not a minimum force. That was the main idea there. The block does not stop at the mean position. Have a look at this. It's a standard model. Huh? Next one. Next one. Any doubts on this? Please ask. We have a vertical ring. So this is a fixed vertical circular frame. So we got a spring here like this. So this is a movable ring. Spring constant is K. Gravity is there. Mass of the ring is m. It's a movable ring of mass m. This distance was r. This distance was 6r. Meaning radius of this ring is 3r. So be careful. Radius is not r. Radius is 3r. Okay. Now the natural length of the spring is 2r. That means initially the spring is elongated, right? Can you tell me what is the initial elongation? So this is point A and this is point B. Initially, what is this total length? 7r. But what is the natural length? 2r. मतलब कितना elongate हुआ? 5r. Agreed? That means spring is in a elongated state. Now, if you just disturb it a little, what do you think will happen? The spring will get pulled like this, isn't it? The spring will get pulled by the ring will get pulled by the spring and it starts sliding on the vertical frame. So ring is released from A. And this thing, the spring will start dragging this small thing and the ring reaches here. It becomes like this. So find the speed. A centripetal, A tangential when it reaches B. Hope the question was clear. Initially, the spring is horizontal, total length 7r, but natural length is 2r. Once you push it, the ring will get dragged by this spring and it slides to B. So once it reaches B, it will have some speed. So find the speed and centripetal acceleration and tangential acceleration at B. Wait, I'll do one thing. Let's say natural length is 2l. This is 6l. This is l. Radius is 3l. Go better because unless you'll get confused, you'll think radius is r. Radius is 3l. Let's keep everything in terms of L. Same thing, but yeah, I just change the variable. Anyone didn't get the diagram, please ask. Question is clear? Go ahead, you got 2-3 minutes. How do we do this? Speed is 5L. Did you even consider spring energy, God? Or did you just take MGL and finish it off? There is a spring potential energy, there is a gravitational potential energy. Try. You know your initial state, you know your final state. You need to find the elongation in the springs. Think. Take a minute. I'll just get some water and come. Any answers? Can you tell me what is the elongation of the spring at B? Start with that in case you're confused how to start. Find the elongation at A, find the elongation at B. So you need to know the elongation first. Then step 2, define state 1, state 2. They're already defined A and B. And then potential energy, kinetic energy. Elongation at B is 3L, right? Right side. See, it looks tough, but it is actually easy only. So when the ring is here, and when the ring is here, if you look at the lengths here, this was L, this was 3L, this was also 3L. That means this was 5L. Agreed? That means if you see elongate, so this is point A and this is point B. So elongation at A was 7L, total L minus 2L, that was 5L. So by the time it came to B, the length of the spring became 5L. So elongation at B was length of the spring 5L, but the natural length is 2L, 3L. State 1, state 2. I will take this as a reference line. Gravitational potential energy, 0. Kinetic energy, 0. You're starting from just spring energy, half K elongation square, that is 5L ka square. State 2, gravitational potential energy, you went by a height of 3L, so mg 3L. Kinetic energy, half mv square, that's what we need to find. Spring potential energy, half K x square, x is 3L. Remember, x is the elongation or compression from natural length. It is not length of the spring. There is an external force, normal reaction, but work done by normal is 0. Therefore, energy in state 1 is equal to energy in state 2. So we get half K 25L square is equal to 3 mgl plus half mv square plus 9kl square by 2. Bring it this side. 25 minus 9, 16. 16 by 2, 8. So 8kl square minus 3mgl is half mv square. Therefore, v is equal to 2 by m. 8kl square minus 3mgl ka root. That's your answer. Check. That's your speed, everyone. Then A centripetal is the easiest one, v square by r. That is always the easiest one. If you find the speed, your job's done there. Have a look at this page, everyone. Anything you're not convinced here, please ask. Right? Then you want to find A tangential and A centripetal. Fair enough. So we have a ring here. What are the forces acting on this? Your weight mg, normal reaction. Now remember, the spring force will be in this direction. Don't forget, this length was 4L. This was 3L. So this angle was actually 37 degrees. And this angle was 53 degrees. This would be a spring force, which is K into elongation was 3L. These are all the forces. And acceleration, this will be A tangential and this will be A centripetal. I didn't ask you, but they can ask you normal reaction also. So that would be mg plus the spring force is K 3L cos 53 minus normal reaction is mass into A centripetal. K into 3L sine 53. That is a tangential force is mass into A tangential. There you got everything. A centripetal is v square by r. You get A tangential, you got A centripetal, you got velocity. I can even find normal reaction. Any doubts on this? Next one. Check it out. Anything you're not clear, please ask. Great. Next one. Potential energy of linear objects. Now this we are going to do in more detail in next chapter, center of mass and collisions. But let's see the idea here. So if you got a rod here, a uniform rod, mass m and length L. And you want to find the potential energy of this rod. Now, tell me one thing, if I take this thing is L, can I say MgL? Does it even make sense? Meaning, when you say MgL, do you mean to say all this mass is at this height? No, right? So the mass is uniformly distributed. So you can actually make a very, a decent guess. This point is at L, this point is at 0. दोनों का average कितना होगा? L by 2. If I go 1 point below here, 99, and this is 1, what is 99 and 1 ka average? 50. If I go one more point, 98 into average, 50. 75 and 25, 50. If you can have an estimate, you can see. That means for all the points, the average is a midpoint. So I can simply replace the rod with a single point at the center and I can solve all the problems. Right? But let's prove it mathematically also. So let's say at a height x, consider a very small piece dx. So for the small piece, the mass dm will be total mass by total length into length of the small piece dx. For this small piece, the potential energy will be dm g and the height is x. Therefore, the total potential energy of the rod will be integral du, which is integral mg by L x dx, 0 to L, which turns out to be mgl by 2. Or you can simply take mg h average, where h is the average, this thing. So we can always replace linear objects. Again, valid only for replace or linear objects. If you take cones, sphere, you can't do this. We can replace uniform linear objects Yeah, able to hear me, right? I am on the hotspot, so my desktop is not working, so someone has to respond.
Yes.
Can you hear me? Okay, so let's continue till this Wi-Fi comes. I don't know what the hell happened. So when you keep this rod horizontal and when you make it vertical, we can clearly see this center here. Yeah, one sec, it is back. Yeah. So when you take this rod horizontally and when you make it vertical, so you can replace this entire rod with a point mass at the center M. And you can say the potential energy of the rod. So initially potential energy is 0. Finally, potential energy is mgl by 2. So if someone asks you what is the work done to, lift the rod, work done is change in energy, which is mgl by 2. Now I can even take shapes like cylinder. Cylinder is also a linear thing. I can take even cubes or cuboid. Let's say if I take a cuboid here, let's say this is length L, this is breadth B, and this is height H. So in all these questions, you can simply replace them with mass M here of height H by 2. I can replace here with height H by 2. And if they ask you the potential energy, you can simply say mgh by 2. It works for linear objects. Have a look at this. Check it out. Clear, everyone? So let's see a question on this. So let's say we got a chain here. L by 4th of the chain is hanging outside. It's a chain of mass M and length L. So the question is, how much work should you do in order to put this hanging chain back on the table? Means you want the chain to become like this. You're getting? You want to put the chain back on the top. Find work done to put the hanging chain back on the table. Let's get this easy one. This would be a standard Bensel question. Right, Devansh. 68. That is such a weird number, right? See now, for this thing, the hanging part, the only headache is the hanging part here. If the total chain ka mass is m, what is the mass of the hanging part? M by 4, isn't it? Mass of the hanging part is m by 4. Where is the center of mass of this hanging part? It's called center of mass. We'll see later on. That will be L by 8. So you want to take this from here and put it on the table. So work done is change in potential energy, which is mass m by 4. I don't want the full chain. You're only interested in this 1/4 of the chain G, and the height is L by 8. That's mgl by 32, isn't it? Check it out. So the main idea was that you take half of the height, but the mass is also 1/4 because you're not putting the full chain. Kaushan, got it out? Clear, everyone? Easy. Let's see one more like this. Let's see one more. We got a cube of mass m and side is L. Now what you did, this is cut into 64 equal cubes. And then what you did, you place them one on top of another. So this is cube 1, cube 2, cube 3, so on till cube 64. So you took this big cube and you cut into 64 identical cubes, and the cubes are stacked on one another. Cubes are stacked on top of each other. Find the change in potential energy. So initially the cube is on the ground, one big cube, it'll have some potential energy. When you cut this and put the cubes one on top of another, they'll also have a potential energy. Find the change in potential energy. How do we approach this? Two 55 by 2. That looks too big actually. Fifteen by 32. Okay. Let's see. First thing, when you cut this into 64 cubes, what will remain constant when you cut a cube? When you cut a cube, what remains constant? The volume, isn't it? So what is the initial volume of the cube? L cube. So let the side of the cube be A. So we get the volume is L cube is 64 into A cube. So we get A is equal to L by 4. That means each of the small cubes this thing will be L by 4. So now when you're stacking 64 cubes one on top of another, 1, 2, 3, everything. So this height will be 64 times L by 4, agreed? So that means this height is 16L. So this entire thing will behave like a rod. Doesn't this look like a rod of height 16L? So now when you look at your question, so we have our cube here and we have a rod here. Basically, you made the cube into like a rod indirectly. This height was L and this height was 16L. Mass is still same. Mass didn't change. So I can replace this entire thing with a mass M here at a height L by 2. I can replace the entire thing with a mass M here at a height of 8L. So change in potential energy is mg 8L minus mg L by 2. That is 15 mg L by 2. Check. Is that making sense, everyone? So this whole setup will look like a big rod of length 16L. All clear with this? This is how you do when you have, if you don't have point objects but you have extended objects, this is how you find. For other shapes, we'll see later on. The next thing. Next thing. Vertical circular motion. Now, you just need to understand one main point in this. If you got this, the entire concept is simply work per energy only. So consider a pendulum of length L and mass M free to move in a vertical plane. Yeah. So this is a string. And this is length L. Now, when you look at this in the lower hemisphere, as long as this particle is moving in the lower quadrants, if you try to draw the FBD, angle theta, this force will be tension. This would be mg cos theta. There will be also the centrifugal force mv square by L, meaning the tension will be mg cos theta plus mv square by L. The tension will never be zero. In the lower quadrants. So as long as this pendulum is oscillating only in this bottom quadrant, the lower hemisphere, the tension can never be zero because both the forces are acting in the same direction. Tension will always add up. Clear with this? The problem starts when you start going in the upper quadrant or the upper hemisphere. This is where the whole story is. All clear with this page? Now, if you go in the upper hemisphere, the problem is so this guy was going in a circle like this. If you take this angle to be theta, we have tension. And we have mg cos theta because this angle is theta and this is mg. And the centrifugal force is mv square by L. Now, if you try to calculate the tension, we'll get T plus mv square by T plus mg cos theta is mv square by L. So we get tension is mv square by L minus mg cos theta. So now you tell me, who is actually trying to keep the string, tight? The centrifugal force. Who is trying to make the string loose? Mg cos theta. So these are the two people who are fighting now. If you see in the lower quadrant, both were adding up. But once you go to the upper quadrant, they both started fighting with each other. So now the issue is, as you go up, what will happen to your speed? Speed will decrease. If your speed is decreasing, that means your centrifugal force is decreasing. That means that one force which is helping you to keep the string tight is becoming weaker and weaker. But as you go up, what happens to mg cos theta? As you go up, mg becomes stronger and stronger. You're getting what is happening? So as you keep going up, the one force which is keeping you, the string taut is tight is the centrifugal force, which is decreasing. But the mg cos theta component is increasing. So there is a possibility the string can become loose and this won't complete a circle only. So as particle goes up, speed decreases. Therefore, mv square by L decreases and mg cos theta increases. Theta is becoming zero, so cos zero is the maximum. So there is a possibility of t becoming zero. This is the word they'll use, string becoming slack. Slack meaning zero tension. Now you think about it. So, but if you want this to complete the vertical circle, at which point the centrifugal force is the weakest? At which point speed is minimum? At the highest point. So at your highest point, your mv square by L is the weakest. At your highest point, mg cos theta is the strongest. So somehow, if you can survive there at the highest point, that means you'll always survive. Because once you reach the highest point, next moment when you come down, your speed will increase again. So centrifugal force will again become stronger. You're getting what is happening? So as you keep going, you're becoming weaker and weaker. So I'm saying if your weakest centrifugal force can balance your maximum mg, that means ab kuch bhi karo, centrifugals will always balance. Is that making sense? It is like, let's say if I have two teams, team A and team B. Now look at the statement. If the weakest person in team A is stronger than the strongest person in team B, that means any fight between the teams, A will always win. Meaning, just to give you an idea, let's say power levels are 100, 90, 80, 70, and 60. Let's say iska power levels are starting from 50, 40, 30, 20, and 10. If you see your weakest member 60 is stronger than the strongest member 50. That means no matter which two people have a fight, A will always win. Kind of making sense. So we are trying to do something here. If your weakest centrifugal force is stronger than your maximum mg, then the string will never become loose. So at the highest point, mv square by L is weakest. And mg cos theta is max. Right? So if you want to complete the vertical circle, so this is what we should do. So please have a look at this page. Let's see in the next page, how much is that value? This is the main idea of entire vertical circular motion. As you go up, you become the centrifugal force. The one who is actually helping the string to become tight becomes weaker. The mg keeps becoming stronger. So somehow, if centrifugal force can defeat that guy even at the highest point, then you'll always be safe. Next one. Any doubts? So now, if you look at your diagram, so this is your highest point here. Let's say your velocity is VH. Now, if you look at the forces, tension, your mg, and your centrifugal force is mvh square by L. So we get tension plus mg is equal to mvh square by L. Since you don't want your string to become loose, the tension must be always greater than 0. So mvh square by L minus mg must be greater than equal to 0. Therefore, vh must be greater than equal to root gl. There. So therefore, at the highest point, the speed should be minimum root gl. We need to have a minimum speed of root gl to complete the circle. Is that making sense? So at the lowest point, let the speed be v. This is state 1, this is state 2. So if you take energy in state 1 is equal to energy in state 2. Energy in state 1 is half mv square. At the highest point, the velocity is half mvh square. Potential energy mg, radius is 2L. Take that vh and substitute here. Half mv square, vh is gl. This is 2mgl. You end up with v is equal to root 5gl. There. This is your second condition. So velocity at the lowest position Both are same only actually. Must be at least greater than equal to root 5 GL. So if you want to complete a vertical circle, highest point my speed should be at least root GL. If you want to complete a vertical circle, same statement. At the lowest point, then you should have speed root 5 GL. So it means if you start here with root 5 GL, when you reach top, you'll have root GL. Making sense? This is your condition. So if you don't give at least root 5 GL, this guy is not going to complete a vertical circle. It will become loose even before that. Let me show you how that looks. So the minimum speed at the lowest position is root 5 GL. Minimum speed at the highest position is root GL. Both are one and the same. When you take the highest position ka root GL, you'll get the bottom में root 5 GL. Any doubts on this page? Please ask me. If you got this, I think you got the whole story of vertical circular motion. Generally, when you go to the highest point, you generally get sometimes speed 0, but not true. Think about projectile motion. Is your speed 0 at the highest point? You had u cos theta. That was a catch. So here, if your speed becomes 0 at the highest point, you will have problem. This thing won't complete a circle. This will fall down. Any doubts on this page? So how does this look if your speed is less than root 5 GL? See. So let's say your speed was u, which is less than root 5 GL, means you didn't give enough speed. Now what would happen? You will go like this. At some point here, the tension becomes 0. So this is the point where the tension becomes 0. So after this, it won't go in a circle. The particle behaves like a projectile. So this guy will start going like this. And if you look at your string becomes like this. The string is loose. Able to visualize the motion? So this part of the motion is a parabola. It's a projectile motion. So when the string is initially there, this is the tight string. This is what will happen if you don't give enough speed.
Vertical circular motion. Objective: to study the one end of a massless, inextensible string of length L.
Able to hear the audio, right?
is fixed to a fixed point O, and its other end is tied to a very small bob of button push at the lowest
So if you just
point.
push it,
A in the velocity is the bob takes a circular path of radius L in the vertical plane.
this is how
Let's
it will go in a
divide the
vertical
circular
plane.
path the bob may take into 4 quadrants around point O: 0 to 90 degrees, 90 to 180 degrees, 180 to 60 degrees. Consider the bob at point P.
This is the lower
where
quadrant I was
LP
talking about.
vertical is tangent.
Now, when you're in the lower
Gravitation
quadrant, if you look at the
relative to
forces,
direction,
mg cos
with
theta and the centrifugal
is
force,
mg
we
cos
just put it
theta.
there. Matlab, tension can never be zero in the lower quadrant.
If the initial velocity of the bob is very small, it may not be able to achieve angles greater than 90 degrees,
So it will be just in the lower quadrant.
it simply traverses back the path it takes. If initial velocity of the bob is greater, it may cross the horizontal line, but will not be able to reach the highest point. When the bob progresses into the second quadrant, tension in the string gradually
Can you see how the ball
decreases
goes?
and becomes zero at some point.
This is what I was saying. If you don't give enough velocity, the tension becomes zero and this thing starts going like a projectile. So we're able to see the graphic.
When tension
And
in the
then
string becomes
again,
zero,
and the string becomes tight,
becomes slack.
this is
and
like
the
a
bob
continuous
undergoes
circle.
projectile motion from this point onwards. Minimum initial velocity,
But if you can give enough
where
speed,
initial velocity of the bob is sufficient
then
to
you'll just complete a
the
circle.
circle. At the
You see,
height
it's a non-uniform circular motion. Speed is not constant. As you go up, you slow down. As you come down, you speed up.
B,
And this is all the proof that we did just now.
Square root of G.
GL. This is the minimum velocity the bob can have.
Clear? So this is the picture I was saying. There you can see here, this was the projectile motion. Clear, everyone? If you got this, this is the whole story of the projectile motion. So as you go up, you need to have at least a minimum speed to complete the circle, or else you're not complete. Clear? Next thing, so if you look at the velocity profile, this is not a big deal. You can just calculate with conservation of energy. If your speed here is u, which is greater than root 5 gl, then when you reach here, your speed becomes root over u square minus 2 gl. This comes from conservation of energy. At the highest point, the speed becomes u square minus 4 gl. Be careful, the speed should be at least root 5 gl at the bottom. If it is less than root 5 gl, it won't even reach the top. Now, if you try to see the free body diagrams at the lowest point and the highest point, so here the force will be tension at the lowest point, mg, and the centrifugal force both will add up. At the highest point, tension th, mg. So automatically tension at the highest point is actually a little less. So tension at the highest point will be mv square by L minus mg. Tension at the lowest point is mg plus mv square by L. If you take the difference, tension at the lowest point minus tension at the highest point, you will always get greater than equal to 6 mg. This is a straightforward CET equation in the exam. CET mains of bit 7 question, but only thing this is valid when your u is greater than root 5 gl at the lowest position. Meaning no matter how much speed you give, the difference in tension is always 6 mg. As long as it is greater than root 5 gl. It's a standard result which you should definitely remember. Exam like mains of bits it comes, it will be a waste of time to solve the whole thing. You won't have time. See, it is a direct result. What is the difference in tension between the highest and the lowest point in a vertical circular motion? 6 mg. You can calculate the values and you can check. So this is your VH. If you substitute and subtract, you will get 6 mg. Clear, everyone? Any doubts on this page? So if you see in vertical circular motion, the main results are what? Highest point by minimum root GL, lowest point by minimum root 5 GL, difference in tension 6 mg. These are the three main ones. Now, what if instead of a string, if I use a rod? If a light rod is used instead of a string. What is the difference between a string and a rod? What was the problem for the string? The moment you try to push the string, it becomes loose, right? But rods can push and pull. So we don't have the problem. So therefore, you can have zero speed at the highest point. Since rods can push at the highest point, the body can have zero speed. Because previously, because to balance mg, you needed centrifugal force, isn't it? But now the rod can push and balance mg. You don't need any centrifugal force. We can have zero velocity because the rods won't become slack. Rods can never become suddenly, like a rubber band. They don't behave like rubber bands. So the idea was this. So at the lowest point, if you have zero here, we can have speed v0. That is because you have mg. The rod will push you. Strings can't do this. Strings can't push, they can only pull. So rod pushes it. So you can have zero speed. State 1, state 2, conservation of energy. Half mu square is equal to mg to L. We get u is equal to root 4 gl. So remember the result like this. If they say it is a rod, then they ask you minimum velocity. Then u minimum, or the velocity at the lowest position, is greater than equal to root 4 gl. But if it is a string, velocity at the lowest position must be at least root 5 gl. So don't mix up the results. Always be careful in the question whether they're talking about a rod or whether they're talking about a string. Check. All clear with this? Running the page. Clear na, Soumitra? Archana? Archita, clear with this? Let's see a question. We have a pendulum here. Mass M. This is a string. Length L. Now someone gave velocity u is equal to root 4 gl. Means less than root 5 gl. So this guy will go in a circle. Somewhere it becomes loose here and flies off like this. Tension becomes 0. Find the height when the tension becomes Let me do one thing. Let's say I give this theta. Find theta when the string becomes loose. And find the maximum height reached by the particle. Let's get that. Now, if you're not giving the minimum speed, then you won't complete a circle. So tension will become zero somewhere. It's a string. So minimum was root 5 GL. So at what angle will the tension become zero and what is the maximum height it will reach? Try. Think. How do we do this? Meaning, see, when you see a question, how do you even start actually? Listen to the question. See, you need to understand. Find theta when the string becomes loose. So ask yourself, okay, string becomes loose, matlab, what is it trying to give you indirectly? Tension is zero. So he's talking about a force. Now you tell me, in which chapter did you learn about forces? Laws of motion. And what is the first thing you do in laws of motion? You draw an FBD. Draw an FBD. That's how you start. And then you want to find the speed also there. Now you tell me, now see, these are the words, huh? Find the speed at that point, find the maximum elongation, find that position, find, this height, find this. If you always observe, look at the word there. It is always about some final position. Matlab, you don't care what is happening in the middle. You're only interested about some final point, isn't it? Indirectly, they're telling you initial state and final state. They're telling you use conservations. Now in physics, luckily, you don't have much. You have only two weapons. One is your free body diagrams. One is your conservations. So when you see a question, you always get a word that if they ask you find tension, find acceleration, he is telling you to use an FBD. If they ask you find final velocity, final elongation, final height, when you see the word final or at that position, he's talking about initial and final state. That's your conservations. So we will be developing this algo as we go on, but that is the basic idea. Like, should I use FBD? Should I use conservation? Think. I'll give you 2 minutes. Draw the FBD there. The right side. The angle is right. Get the maximum height. Aaron should try. I'll give you 1 minute for the angle. Cos theta 2 by 3. That looks right. Let's see the angle. So somewhere here, when this is angle theta, this is your mg, this is also theta. So if you look at the forces, this is tension, this is mg cos theta, this is your centrifugal force mv square by L. So we get T plus mg cos theta is equal to mv square by L. Tension becomes 0. So we get mg cos theta is mv square by L. So I get v square is gl cos theta. Great. Now I don't know the speed. So this is initial position, my state 1, and this is my state 2. Now, if you look at this height here, this height was L cos theta. And this height was L. So energy in state 1 is equal to energy in state 2. So initial energy was root 4gl half m u square is half m v square plus, so at this position your speed was v. Plus mg, what is the total height? L plus L cos theta, that is the total height that you gained. So this guy is half m u square is 4gl, that is given. Half m v square is mgl cos theta, we derived just now. This would be mgl 1 plus cos theta. Mgl will cancel everywhere. You will end up with 2 is equal to cos theta by 2 plus 1 plus cos theta. You get 1 is equal to 3 by 2 cos theta. Cos theta is 2 by 3. Check. Conservation of energy and 1 FPD. Question still not over. So what is the maximum height reached by the particle? So ask yourself, do you think it will just stop here? Won't it continue flying like a parabola? So that means यहाँ पे एक Hmax भी आएगा ना extra. So this is not the maximum height. It will still go up and then fall down. So there's an Hmax here. Projectile motion. So you have to add that Hmax also. The question was, what is the maximum height you will reach? The question was not find the height when the tension was 0. So after this point, it becomes a projectile motion. So you have to add that Hmax ka height. Farhan, making sense? Do ask if you're confused. Should definitely try all these things again after the class. What is the Hmax? Try, I'll give you 1 more minute. Soumitra, try. Why are you guys chilling out? You guys are already exhausted or what? I found the angle for you. I found the speed for you. You just need to add that extra Hmax. Try. I'll give you a minute. Let's see. So at this point here, your velocity was v. This angle was theta. This was 90 minus theta, and this was theta. So this becomes a projectile motion. So the extra height you're getting is this h max. And already this was L cos theta. And this was already L. So you just need to add all these things. And what is V? V is V square is GL cos theta. And cos theta is 2/3. So your speed was actually 2/3 GL. And what is H max? V square sine square theta by 2G. So V square is 2GL/3. 2G sine square theta is 1 minus cos square theta. 2G will cancel. L/3, 1 minus cos theta is 1/4/9. That is 5L/27. Therefore, the total height will be L cos theta is 2L/3 plus 5L/27. This is 5L/3 plus 5L/27. Multiply 9, so you'll get 50L/27. That's your max height. Right there, much. Is that clear, everyone? That is how a paragraph will look like. They'll ask you find the angle and find H max. Most people will think L plus L cos theta is H max. No, it won't stop there. It will continue to go higher. All clear with this? So there. So that is a little about vertical circular motion. So next class, when we catch up on Wednesday, we'll continue from here. We will do a few more problems on work power, vertical circular motion. And then we have something called power also. That also we will discuss a bit. And then I think we will be done with the chapter on Wednesday. So Wednesday, we'll wrap up the chapter. And then next week, we are on a break. So next week, there are no classes. Again, we will commence on November 4th. Next week is a Diwali break. And then November 4th, we will be back as usual. We'll start off, after this chapter, we'll start off with center of mass and collisions. So Wednesday, we will wrap it up. So, and last week, a paper do resolve. Wednesday, we will discuss the paper cutouts also. So any doubts in today's class, any other doubts, you can stay back.